Hey folks, welcome to my channel number pen. So there we have the problem on our screen. Integrate the following with respect to x, and we have a very simple function sine 3x. So what's that we've been given? We've been given dy by dx equals sine 3x, and we've been asked to find y, right? So again, problem which you can solve using substitution. And what is your y? Y is nothing but integral of sine 3x dx, right? And what do I actually mean by this? And I want you folks to draw a parallel to what we have learned in first principles, right? And the idea behind the substitution that we are going to make in our next step is to reduce y to a much simpler expression whose antiderivative you're familiar with from first principles, what you learned in differential calculus, right? So the point here is, what is that substitution? It's a very simple substitution. 3x equals t, which means that my 3 times dx equals dt, right? So what is my dx? My dx is dt by 3. I put back everything in terms of t in the above expression, and I have a sine t times my dx becomes dt by 3, and therefore I pull out my 1 by 3. And this is something which I'm familiar with from first principles, right? And what is the answer to this? The answer to this is minus 1 by 3 cos t. Why is that? And of course, remember to add your constant in all these problems, right? See, because when I differentiate cos t, I get a minus sine t. And when I differentiate minus cos t, I get a sine t, right? So therefore, integral of sine t dt is nothing but a minus of cos t, right? So when you differentiate minus cos t, you get back your sine t, right? So this is what we have, but our final answer is in terms of t, so we put it back in terms of x, which is the usual expectation. And my final answer to this problem in terms of x is minus 1 by 3 times cos 3x plus c, right? And why is that? Because of the original substitution t equals 3x, right? So let me highlight the final answer in pink. So there we are. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.